browsing will provide a hacker with unauthorized access to areas of your server or application. The cause of such vulnerabilities are usually due to misconfiguration of web server permissions or inadequately programmed application logic. Forcible browsing can provide users or hackers with unauthorized access to data and can result in access to functionality outside of their normal permissions. We'll talk about some of the defenses in this module. When a site is on the internet, the web server is configured to serve very specific files and directories to the general public. As a user, you access the web server, right? But the question is, how do you know which files are accessible? How do you know which files are available to you? You can kind of think of forcible browsing as blindly throwing darts at a dartboard, hoping to hit the bullseye. You generally know the direction of the board, but you're not really going to know if you're going to hit or miss. Within a web server, there are many files that may or may not exist, and as a user, you have access to a subset of them, right? In this case, this user has access to these green files here. But how does a user know if they have access to another page, such as the config admin page? In most cases, they would just forcibly browse to it and guess. Generally, they'll have access to these user pages here, the green ones, right? But hopefully, not the red one here. The only way you would find out is if the user browsed to it directly. If it exists, hopefully the user doesn't have access to the page and he's restricted from it. But if not, then he's just performed a vertical escalation exploit. He's able to access the admin pages from a normal user account. This is a serious vulnerability. Let's take the previous scenario one step further. If a hacker knows the links to your site, the ones you see here that the user was accessing before, if they forcibly browsed onto these links, would they be able to have access to your site? If a site's actually programmed horribly, I've seen the case where accessing these types of files actually gives the hacker a valid session to your site. I've seen an even stranger case where, because the application didn't know how to handle this situation, it actually gave the hacker full admin rights because the user didn't belong to any programmed group. It's a very interesting vulnerability and something that you have to consider when it comes to forcibly browsing through your site. And it goes to show that forcible browsing is a real exploit against most major applications. As for a real-life example, in June of 2010, Blue Cross ran into a forced browsing vulnerability where customers were able to forcibly browse other Blue Cross customers' insurance profiles. By directly visiting different URLs, it exposed over 230,000 sensitive user profiles kept for insurance purposes on Blue Cross's website. It resulted in Blue Cross having to notify the affected customer, and one customer saying, "There's not one place that has more information on you than your health insurer." Let's now talk about some of the defenses that we can employ against forced browsing. And so some of the best practices that we'll be discussing will include using techniques such as page-level authorization, as well as programmed authorization to protect your site from forced browsing. This is a typical use case scenario of accessing a website. You have a browser request, app server configuration, and which pages are restricted or allowed within the app server configuration. And this is your typical page-level authorization. Essentially what happens is the browser requests information from the app server, and it's either restricted or allowed. In this case, it's allowed so that you can see the pages rendered in the actual browser itself. In the case where either policy or certain hardening of the web server has declared that directories or pages are not allowed, what happens is upon the browser's request, the configuration will actually reject the page from being served. So this is page-level authorization. And there's certain problems with using page-level authorization, specifically that you pretty much have to configure every single page and a whole large set of permissions. Now at this point you might be thinking page-level authorization is exactly the answer I've been looking for. Not so fast. There are certain problems with it. Let's take an example here where every user is allowed to access this page, account.jsp. Now by default, the action that they're going to be allowed to do is to read. And so what's going to happen is when a user accesses this page, The server configuration, remember this little red and white thing is the server configuration, says we're going to check access to account.jsp, and since this user is allowed access, we're going to give them the ability to read it. That's the benefit of page level authorization, right? Because anybody that passes this filter here is able to access the page. Now, what's the problem with this? Well, let's consider the second scenario. What about the situation if the user changes his action to delete, which is actually a valid function within the system as well? And this function would be to delete an account. The first problem you can see is that we're only checking for access to a certain page, right? Account.jsp. And when the server looks at this, it says, well, does this user have access to account.jsp? Yes, he does, because all users do. And so what it'll do is it'll allow the user to the page and then allow the user to perform the action of deleting it. And so this is one of the problems with page level authorization, is that if you want to allow specific functionality within the page to certain users, it's not that granular to be able to handle that. And a forced browsing weakness can allow attackers to access functions that may be hidden within your page. And so that's why you need other forms of authorization as well. So that's why we have to discuss this very last topic of programmed authorization. When we're talking about forced browsing, and we saw from the previous example that page level authorization by itself really wasn't enough. What we have to consider is, what can we do aside from page level authorization? We can still continue to use page level authorization as we are here, but we need one more step, and the answer to that is really to use code to supplement our logic. And really what that means is to use programming, right? Use programming to inspect certain users. In addition to checking whether or not a user is allowed to access a certain page, we also want to consider whether or not a user belongs to a particular role and what kind of permissions belong to that role as well. We also want to discuss what kind of functionality is available to that user while still allowing access to certain pages. In the previous example, where two users were allowed to access the same page, we could also restrict the functionality available to each user by using programmed code. One user may be allowed to perform the action of read, while another user could be allowed to access the delete function. Okay, great. Now we're at the end of the chapter, and let's go through some of the things that we learned about forced browsing defenses. The first thing that we discussed was page level authorization, where each page checks to see if the user is authorized to have access. Generally speaking, no further checks are performed. And it's kind of like having a key to a door. You either have access to the key or you don't. One thing to be considered is that it's very difficult to control page level authorization for a whole bunch of different files. And so you shouldn't really manage this at a page-to-page level. Really what you should do is have a more overall architecture for page level authorization, maybe a single place to manage permissions for a subset of pages. And really this works because of a very simple reason. There's a lot of automated tools out there that will forcibly browse certain pages, things like admin.jsp. If you don't have adequate protections on your web server against that, you're going to be in a lot of trouble. The second thing we learned was usually page level authorization is not enough because there's going to be different levels of functionality within your pages as well. And for that, we have to use programmed authorization, pretty much using code to determine a user's authorization to access certain functions. And this is pretty much what allows certain roles within pages, right? If a user logs in to your site, what allows them to access the admin page versus access normal read functions? Typically, this is done through program logic. This is the end of this chapter, and I hope you enjoyed it. Remember that both of these techniques can be used in combination, not necessarily independently. Take care.